Hi, good morning everybody. In the previous lecture, we have seen scalar triple product of three vectors. Also, we have taken the problems from exercise 5.5. Now today we are going to see the new concept, that is volume of a parallelepiped which coterminous edges A bar, B bar, C bar is the scalar triple product of A bar, B bar, C bar. Volume of a parallelepiped which coterminous edges A bar, B bar, C bar is scalar triple product of A bar, B bar, C bar. Now in the textbook, the proof of this theorem is given, but for this academic year, due to this COVID pandemic, the proof of this theorem is deleted. Only we have to take the statement of the theorem as a formulae. The next theorem is also given, whose proof is also deleted for this academic year. So the volume of a parallelepiped, this is one. So see how the A bar, B bar, C bar are coterminous edges. See, I will draw the parallelepiped here. Just 1 minute. So here the coterminous edges are, this is A bar, this is B bar, and this vector is C bar. So this is parallelepiped with coterminous edges A bar, B bar and C bar. And the volume of this parallelepiped is the scalar triple product of three vectors A bar, B bar, C bar. Now the next theorem, which is also given in the textbook with proof, but the proof is related, and that theorem is volume of a tetrahedron with coterminous edges A bar, B bar, C bar is 1/6 into scalar triple product of A bar, B bar, C bar. And here I will draw the tetrahedron. And so here the coterminous edges are A bar, B bar and this one C bar. So the volume of this tetrahedron is 1/6 into scalar triple product of three vectors A bar, B bar, C bar, or box product of three vectors A bar, B bar, C bar. So these two formulae, volume of a parallelepiped and volume of a tetrahedron. So next, the new concept which is newly included in our syllabus, that is vector triple product. Vector triple product. Vector triple product of three vectors. See the definition for vectors A bar, B bar, C bar. For three vectors A bar, B bar, C bar, in this space we define the vector triple product as A bar cross B bar cross C bar. This is vector triple product of three vectors A bar, B bar, C bar. It is equal to A bar dot C bar into B bar minus A bar dot B bar into C bar. So this is the definition of vector triple product of three vectors. See, A bar cross B bar cross C bar is equal to A bar dot C bar minus A bar dot C bar into B bar minus A bar dot B bar into C bar. Now see the properties. Properties of vector triple product. Properties of vector triple product. The first property is A bar cross B bar cross C bar is equal to minus B bar cross C bar cross A bar. See, this is cross product. Vector triple product is nothing but the cross product of two vectors. Now A bar cross B bar cross C bar is equal to minus B bar cross C bar cross A bar, because vector product is anti-commutative. We know that P bar cross Q bar is equal to minus Q bar cross P bar. So using this property here, A bar cross B bar cross C bar can be written as minus of B bar cross C bar cross A bar. Second property, A bar cross B bar cross C bar is equal to A bar dot C bar into B bar minus B bar dot C bar into A bar. Third property, A bar cross B bar cross C bar is not equal to A bar cross B bar cross C bar. Fourth property, I cap cross J cap cross K cap is equal to zero vector, where I, J, K are unit vectors along the coordinate axis X, Y, Z respectively. At that time, I cap cross means I, J, K, these are unit vectors along X axis, Y axis, Z axis respectively. So their vector triple product is zero vector. Fifth property, see, A bar cross B bar cross C bar is a linear combination linear combination of B bar and C bar, hence it is coplanar with B bar and C bar. See how, if we observe the definition of A bar cross C bar, explanation for this fifth property, see, A bar cross B bar cross C bar is equal to, what is the definition of vector triple product? It is A bar dot C bar into B bar minus A bar dot B bar into C bar. You know that dot product is scalar, so if this is X and this is Y, then it is X into B bar minus Y into C bar, and this is nothing but this linear combination of B bar and C bar. And we know that if we have two vectors A bar and B bar, then the linear combination of these two, that is X into A bar, Y into plus Y into B bar, this vector means these three vectors are coplanar. See, if we have two vectors A bar and B bar, then the linear combination of these two vectors, that is X into A bar plus Y into B bar, and this vector is coplanar with A bar and B bar. So here this vector triple product is the linear combination of B bar and C bar, so it is coplanar with B bar and C bar. It means that the vector A bar cross B bar cross C bar, this vector, and B bar comma C bar are coplanar. So this is fifth property. So this is everything about the vector triple product of three vectors. Now let's see some examples. So first we see the examples on first two theorems which we have taken as a formulae for this academic year. Find the volume, or first question, if the vectors 3i cap plus 5k cap comma 4i cap plus 2j cap minus 3k cap and 3i cap plus j cap plus 4k cap, 3i cap plus j cap plus 4k cap are coterminous edges of a parallelepiped, are coterminous edges of a parallelepiped, then find the volume of parallelepiped. Then find the volume of parallelepiped. So right, see, coterminous edges are given. First denote these three vectors as A bar, B bar, C bar. So let A bar is equal to 3i cap plus 5k cap, B bar is equal to 4i cap plus 2j cap minus 3k cap, and C bar is equal to 3i cap plus j cap plus 4k cap are coterminous edges of a parallelepiped and we know that if A bar, B bar, C bar are three coterminous edges of a parallelepiped, then the volume of that parallelepiped is volume of parallelepiped. Therefore, the volume of parallelepiped is equal to the box product A bar, B bar, C bar, it is equal to. Determinant. Whereas how to solve the box product means scalar triple product of three vectors. That is nothing but we have to use the definition of this scalar triple product in the form of determinant. In the determinant, it is 3 by 3 determinant in which the first row is the coefficients of ijk in A bar, second row is coefficients of ijk in B bar, and third row is coefficient of ijk in C bar. Now it is in A bar it is 3. Now the coefficient of j cap is not here, the term with j cap is absent, so we have to take the coefficient of j cap as 0. So it is 3, 0, 5. In B bar it is 4, 2, minus 3, and in C bar it is 3, 1, 4, and it is equal to, solve this 3 by 3 determinant. It is 3 in bracket, leave first row, first column, it is 2 into 4, 8, minus 1 into minus 3, minus of minus 3 become plus 3, minus 0 in bracket, leave first row, second column, 4 into 4, 16, minus 3 into minus 3, minus 9, minus of minus 9, plus 9, plus 5 in bracket, leave, now this 5 lies in first row and third column, so leave first row and third column. So take the determinant of these 4 elements, that is 2 by 2 determinant, it is 4 into 1, 4, minus 3 into 2, 6. So it is it is equal to 3 into 8 plus 3, 11, minus 0 into everything, that is 0, plus 4 minus 6 is minus 2, so it is plus 5 into minus 2. So it is 33 minus 0, that is no need to write it, and 5 into minus 2, minus 10. So 33 minus 10, that is 23. So therefore the volume of parallelepiped is 23 cubic units. The volume of parallelepiped is 23 cubic units. So next question. Find the volume of a tetrahedron. Find the volume of a tetrahedron whose vertices are capital A minus 1, 2, 3, B 3 minus 2, 1, C 2, 1, 3, 2, 1, 3, and D minus 1, minus 2, 4. Coterminous edges of tetrahedron are not given. The vertices of tetrahedron are given. So you see, if this is the tetrahedron, This is tetrahedron. See here, vertices are A, B, C and D. So these are the vertices of tetrahedron which are given, and here we have to find out the volume of this tetrahedron. We know that the three coterminous edges means if this is A bar, small a bar, this is B bar and this is C bar, then its volume is 1/6 into box product of A bar, B bar, C bar. Now here the vectors are not given, vertices are given. But now here this is AB bar, AC bar and AD bar. So the volume of this tetrahedron is nothing but 1/6 into box product of AB bar, AC bar and AD bar. Means here we have to find out AB bar, AC bar and AD bar. So let's see, or let's find AB bar, AC bar and AD bar. Now see, let small a bar, small b bar, C bar, D bar be the position vectors. P dot V means position vectors of vertices capital A -1, 2, 3, B 3, -2, 1 and C 2, 1, 3, D -1, -2, 4 respectively of a tetrahedron. See here, A bar is the position vector of point A. Point A has coordinates -1, 2, 3. So the A bar is -I cap plus 2j cap plus 3k cap. This is A bar. B bar, it is 3I cap minus 2j cap plus k cap. C bar, 2I cap plus j cap plus 3k cap. And small d bar, it is the position vector of the point capital D. So its position vector is -I cap minus 2j cap plus 4k cap. So let's see once again, A bar, B bar, C bar, D bar, -I cap plus 2j cap plus 3k cap. B bar is 3I cap minus 2j cap plus k cap. C bar is 2I cap plus j cap plus 3k cap, and D bar is -I cap minus 2j cap plus 4k cap. As we have seen, we have to find out AB bar, AC bar and AD bar. Now AB bar, it is equal to position vector of the point B minus position vector of the point A, that is B bar minus A bar. It is equal to, see, B bar minus A bar, 3I cap minus minus become plus, that is 4I cap. 3I cap plus I cap, 4I cap. Next, my B bar minus A bar, minus 2j cap minus 2j cap, j cap, minus 2 minus 2 minus 4j cap, k cap minus 3k cap, that is minus 2k cap. This is your AB bar. Now AC bar, it is equal to C bar minus A bar, C bar minus A bar. See, 2I cap minus minus become plus, that is 3I cap. J cap, C bar minus A bar, J cap minus 2J cap minus J cap. C bar minus A bar. Now 3K cap minus 3K cap, that is 0 into K cap. This is your AC bar. Now AD bar, it is D bar minus A bar, it is equal to, see, the vector D is here, D bar minus A bar, minus I cap, and minus minus become plus, minus I cap plus I cap, 0 I cap. Next, D bar minus A bar, minus 2j cap, and this minus 2j cap become minus 4j cap. Now D bar minus A bar, 4k cap minus 3k cap, that is plus k cap. Once again check AB bar, AC bar, AD bar, that is B bar minus A bar, it is 3 minus plus 4, minus 2 minus 2 minus 4, and k minus 3k minus 2k cap. AC bar, C bar minus A bar, 2 plus 1 3, 1 minus 2 minus 1, and 3 minus 3 0. AD bar minus I cap plus I cap 0 I cap, minus 2j cap minus 2j cap minus 4j cap, and 4k cap minus 3k cap, that is plus k cap. Okay, now here we have AB bar, AC bar, and AD bar. Now find out box product of AB bar, AC bar, and then AD bar. It is equal to 3 by 3 determinant. AB bar 4 minus 4 minus 2. The coefficients of ijk in AC bar, that is 3 minus 1 0, and coefficients of ijk in AD bar, that is 0 minus 4 1. So it is equal to 4 in bracket minus 1 minus 0, minus 1 plus 1 minus 1, minus 4 into 0 0, minus of minus 4 become plus 4 in bracket. Leave first row second column, 3 into 1 3, minus 0 into 0 0, minus 2 in bracket. Leave first row third column, 3 into minus 4 minus 12, 3 into minus 4 minus 12, minus 0 into minus 1 minus 0. So it is equal to 4 into minus 1 minus 4 plus 4 into 3 12 and minus 2 into minus 12. It is equal to minus 4 plus 12, minus minus become plus 24. Again it is equal to, see, minus 4 plus 12 8, 8 plus 24, that is 32. So here AB bar, AC bar, AD bar means box product of these three vectors or scalar product of these three vectors is 32, and we know that the volume of this parallelepiped is volume of a parallelepiped is equal to 1 upon 6 into box product of AB bar, AC bar, AD bar, and it is equal to 1 upon 6 into 32, and it is equal to 16 divided by 3 cubic units. So this is the volume of a tetrahedron which vertices A, B, C, D. ठीक. Next question. If, see, A bar is equal to I cap plus 2j cap plus 3k cap, B bar is equal to 3i cap plus 2j cap, and C bar is equal to 2i cap plus j cap. You see, A bar is I cap plus 2j cap plus 3k cap, B bar is 3i cap plus 2j cap, and C bar is 2i cap plus j cap plus 3k cap. A bar, B bar, C bar are given, then verify that. Then verify that here we have to verify the vector triple product. A bar cross B bar cross C bar is equal to A bar dot C bar into B bar minus A bar dot B bar into C bar. We have to verify the definition of scalar vector triple product. So to verify the definition, now find out the values of left hand side and right hand side and check whether they are equal or not. If they are equal, then the definition of the vector triple product is verified. Okay. So let A bar, that is I cap plus 2j cap plus 3k cap, B bar is equal to 3i cap plus 2j cap, and C bar is equal to 2i cap plus j cap plus 3k cap. Now first we find the value of left hand side. So to get the value of left hand side, we have to find out B bar cross C bar. So now B bar cross C bar is equal to determinant I cap, j cap, k cap. Now B bar cross C bar. So here the second row is the coefficients of I, j, k in B bar, that is 3, 2. Now the k cap is absent, means it is coefficient is 0. So it is 3, 2, 0. And the coefficients of I, j, k in vector C are 2, 1, 3, 2, 1, 3. It is equal to, see, I cap in bracket 2 into 3 is 6 minus 0 minus j cap in bracket, leave first row second column, 3 into 3 9 minus 2 into 0 0 plus k cap in bracket, leave first row third column, 3 into 1 3 minus 2 into 2 4. So it is equal to 6i cap minus 9j cap plus k cap into 3 minus 4. 3 minus 4 is minus 1. So it is minus k cap. So this is your B bar cross C bar. Now on the left hand side, we have to prove A bar cross B bar cross C bar. So A bar is known. So find out the cross product of A bar cross B bar cross C bar. It is equal to determinant. So see, here the first row is I cap, j cap, k cap. Now second row is the coefficients of I, j, k in vector A, and these are 1, 2, 3. So it is 1, 2, 3. Now the next third row is the coefficients of I, j, k in vector B bar cross C bar, and that is 6 minus 9 minus 1. 6 minus 9 minus 1. It is equal to I cap in bracket 2 into minus 1 minus 2 minus minus 9 into 3 minus 27, minus of minus 27 plus 27 minus j cap in bracket. Now leave first row second column, 1 into minus 1 minus 1, 1 into minus 1 minus 1 minus 6 into 3 minus 18 plus k cap in bracket, leave first row third column, 1 into minus 9 minus 9 minus 6 into 2 12. Once again see A bar cross B bar cross C bar, I cap in bracket, leave first row, first column, first row, 2 into minus 1 minus 2 minus minus 9 into 3 minus 27, minus of minus 27 plus 27 minus j cap in bracket, leave first row second column, 1 into minus 1 minus 1 minus 6 into 3 18 plus k cap in bracket, 1 into minus 9 minus 6 into 2 12, and that is 27 minus 2 25 I cap minus 1 minus 18 minus 19 minus of minus 19 plus 19 into j cap minus 9 minus 12 minus 21 into k cap. This is your A bar cross B bar cross C bar. Give this equation number 1. This is the value of left hand side. Now we find the value of right hand side. Now to verify or to find the value of right hand side contains two terms. In first term, it is a bar dot c bar into b bar. In second term, a bar dot b bar, means here we require a bar dot c bar and a bar dot b bar. So first we find a bar dot c bar. It is equal to. Now see, the vector a and c are there. So we know that how to find the dot product of any two vectors if they are given in the form of ijk. That is 2 into 1 plus 2 into 1, or if we want to keep the order same, that is 2 into 1 plus 1 into 2 plus 3 into 3. That is 2 into 1 2 plus 1 into 2 2, 2 plus 2 4 plus 3 into 3 9, so 9 plus 4 13. A bar dot b bar is equal to a bar dot b bar. So 1 into 3 plus 2 into 2 plus 3 into 0, because in b bar the term with k cap is absent, so here we have to consider the coefficient of k as 0, and so it is equal to 1 into 3 3 plus 2 into 2 4, 4 plus 3 7 plus 3 into 0 0, 7 plus 0 7. Okay, now a bar dot c bar into b bar minus a bar dot b bar into c bar is equal to a bar dot c bar, that is 13, into b bar. What is b bar? 3i cap plus 2j cap plus 0 into k cap minus 7 into c bar, vector c. What is vector c? 2i cap plus j cap plus 3k cap. 2i cap plus j cap plus 3k cap. Again it is equal to, see, 13 into 3 39 I cap plus 26 j cap plus 0 k cap minus, multiply to this vector in the bracket by 7, so it is minus 7 into 2 minus 14 I cap minus 7 into 1 minus 7 j cap minus 7 into 3 plus minus 21 minus 21 k cap. Okay, again it is equal to. Now here take the subtraction. 39 I cap minus 14 I cap. 39 I cap minus 14 I cap become 25 I cap. 26 j cap minus j cap become plus 19 j cap. And 0 k cap minus 21 k cap. 0 minus 21 minus 21 into k cap. What is this? A bar dot c bar into vector b minus a bar dot b bar into vector c. Give this equation number 2 and observe the equation 1 and 2. See, equation 1 is here. The right hand side of equation 1 is 25 I cap into 19 j cap minus 21 k cap, and the right hand side of equation 2 is also 25 I cap minus 9 plus 19 j cap minus 21 k cap. It means that from equation 1 and 2 their right hand sides are equal. It means left hand sides must be equal. So from equation 1 and 2 we get, from equation 1 and 2 we get a bar cross b bar cross c bar is equal to a bar dot c bar into vector b minus a bar dot b bar into vector c. So verified. So today we stop it here, and here our vector topic is over.